Okay, so this is, designing semantic memory for multi-agent systems with Python. I'm just curious, this is my second time speaking at Pydata. Was anybody here last year, 12 months ago, out of curiosity? One person. Okay, obviously made a great impression. Awesome. Okay, well, hopefully I'll leave you with something interesting this time. So, when agents forget, systems fail. A little bit about me. I'm a PM, as you've already heard. The Cosmos DB team have been there for some time. I mostly focus on AI, programmability, and developer experience. Usually I tend to talk to app developers, so it's a little bit a fish out of water for me at a conference like this. I think Pydata tends to be for more machine learning, data science types, or people who have scientific uses for Python and so on. But what we've observed on our team is that quite a lot of those types, those personas, are being asked to build agentic apps because somebody's coming to them and saying, hey, you're the AI guy, you're the AI woman, I want you to build the AI system. So all of a sudden you have to be learning all these concepts and moving away from maybe what it has been that you've been focused on. So, and also we've seen a massive growth in the use of our Python SDK on Cosmos DB, because Cosmos DB is a very good target for agentic apps. So tend to be speaking at these kinds of conferences more often than in the past. So I'm presenting memory as a data engineering problem rather than a prompt engineering trick. And all I mean by that, really, to give a different analogy, you probably heard the expression, any old idiot can build a bridge, but it takes a civil engineer to build a bridge at the right cost. Okay, so, well, any old idiot can build an agentic system with memory. You just stuff everything into the context window and everything's fine, and it's going to cost you an absolute fortune. So I think we've all seen probably, just a show of hands, how many of you are building or going to be building agentic apps? All of you, most of you, almost everybody. How many of you, out of interest, have been coding with a coding assistant for at least the last 6 months and don't do any hand coding yourself? Only a few of you. Interesting. Okay, it's the opposite way around than what I expected, but never mind. We'll get to that. Okay, so yeah, we've all seen, I think, the difference between the demo apps and the production agents. Obviously, there's a big difference. I won't dwell on this, but what I'm focusing on here is not exploding token costs by making memory efficient, and of course, improving the experience for the end user as well for these applications that you're building. So kind of a little bit of agenda here. I'm going to start with a memory taxonomy, nowhere near as complicated as it sounds. A little recap on multi-agent architecture from the last talk, which only one of you saw, so maybe a little bit of an expansion there as well. And then we'll go and move on to intelligent memory. And I have to admit here, I was only going to talk about those 3 areas in this talk. It's probably the first time ever, and I've been doing conference talks for, I don't know, 7, 8 years now, where the time in between I submitted the talk and when I actually spoke, which is probably about 5 or 6 months, something very big happened, didn't it? I think we all noticed this since around November 2025. A fairly major paradigm shift happened in the entire industry. So I couldn't really do a talk on anything to do with AI and agentic apps without mentioning that as well. I'm calling it conversation as code. I'll just leave that hanging as a mystery just to keep you from leaving the room until I've explained what I mean towards the end. And I'll be having some demos, but none of my demos will be live because last time, as the one person who's returned probably remembers, it was a complete car crash and I couldn't show any of my demos, so all my demos are embedded into the PowerPoint, so there's no possible way that they can fail unless somebody has sabotaged PowerPoint in some way. So start with something fairly obvious. Memory is not the same as retrieval augmented generation, obviously. Obviously, there are some similar techniques. You could call RAG memory, but if you do, it's obviously a very different type of memory. Traditional RAG, it seems crazy to be calling it traditional, doesn't it? It's only less than 2 years ago, it was like the latest thing, a complete paradigm shift in everyone's thinking, and now traditional RAG, old hat, old school. Old school RAG, traditional RAG, we're talking about static document chunks, same results for all users, no concept of time or change, typically similarity search only. Well, always similarity search only, different types of similarity searches, obviously vector, text search, and so on. And doesn't learn from interactions. But with agentic memory, we're talking about personalized user facts, grows with every interaction, salience scoring, which I'll come on to, cross-session persistence, and full lifecycle management. So why a database for agent memory? I have to hold my hands up here. Of course, I work in an engineering team for a database. If your tool is a hammer, then everything looks like a nail. So of course, I'm going to say, yes, you need a database for memory. But I think I'm on fairly solid ground here. Most production agentic apps at scale that we're seeing are using databases now. They're not just using dedicated vector stores or JSON stores or things like that. They're needing to manage persistence in the traditional way with transactional guarantees for checkpoint state and TTL policies and so on, hybrid search, meaning combinations of vector search and text search. Hybrid search is a bit of an overloaded term in this context, but I'll come on to that later. And in some cases at massive scale, the types of customers that Cosmos DB has, we have sub-millisecond recall required and multi-tenant isolation, it being a multi-tenant system, global distribution for multi-region agents at scale. So just very recently, apologies, bit of a marketing slide here for Microsoft, we just released LangChain Azure Cosmos DB, which is our Python package that supports the various integrations for Cosmos DB into the LangChain and LangGraph ecosystem. Show of hands, how many are using LangChain? Okay, about half of you in LangGraph? Less than half of you, interesting. Okay, that sort of aligns with our experiences, but I'll maybe mention that later. We've also released very recently, it was announced a couple of days ago at Microsoft Build, an agent memory toolkit, which is another Python library. And I'm just going to be candid here. It does the same thing as the LangChain and LangGraph library, but it's dedicated to the database. And it's providing abstractions and capabilities that are not provided there. And again, just to get cut straight to the chase here, abstractions like LangChain and LangGraph and many others like Spring and Hibernate and other languages and so on. Of course, if you're supporting multiple different data stores or multiple different plugins, you're going to end up with a lowest common denominator, right? There's going to be some compromise. So you end up having to either have escape hatches or you just don't have the functionality that you need. So we've released something separate, but that's not the only reason we're releasing it. And this is maybe a major talking point. We think agentic memory is going to be a first-class capability in databases. And we're maybe one of the first that's actually putting out a library and saying this is directly related to the database. It's not part of a framework. It's providing capability that you can interact with, and it's dedicated to Cosmos DB, which is a database. And we're saying this is eventually where we're moving is that this will be a first-class capability in the database. So the best analogy that I could give here, anybody ever built a materialized view in a SQL table or any database, right? So for years and years before materialized views were a thing in databases, people were just implementing them manually, copying data periodically, or streaming it into some other table to serve the needs of that table because the original table didn't have the required schema and so on, and that became a read-only materialized view. So we see this as the same thing, and we've observed from how many customers are using Cosmos DB for this scenario that it's a repeated thing that customers want. So we want to be very opinionated and provide capabilities that are going to work well with Cosmos DB database for this particular use case and scenario. I'll be showing some demos from a travel multi-agent workshop sample. Well worth looking at this if the whole area of memory and memory systems or memory processing is new to you. You can deploy it just into Azure from the completed folder. It's very straightforward. Or you can go through the exercises of the workshop and it just takes you step by step, building up the different parts of memory that you used. I'm not going to be going into loads of detail, but just mention it if you want to try that out. So this is built with LangGraph and Azure OpenAI and Cosmos DB. So a little show the first demo here then of what this looks like when you do deploy it, just to start illustrating the concepts. There's a profile and memories section. Of course, you wouldn't have this in a real app. It's just for educational purposes, so you can see the memories as they're being stored and compressed. And of course, the code, for those of you familiar with LangGraph, of course, there's a lot more code than this, but the core part is where you are generating a state graph and adding nodes to that graph, and each node represents an agent, and we're using the orchestrator pattern, which is very common with multi-agent scenarios. You have a single agent that's going to delegate responsibility or route the request to different specialized agents. So let's just see some simple thing happening here. So we just start to illustrate the memory, use of memory and storage of memory. So I'm saying I want to plan a 5-day trip to Tokyo for 2 people. And so that's going to respond with something. Problem with pre-recorded demos, you never know what's going to happen. Could you please share your interests and preferences? So it's already been configured to ask for them and store these preferences, and so that it can retrieve them. And so I'm going to say, well, I'm a vegetarian and I prefer boutique hotels in quiet neighborhoods. And of course, it's going to remember those preferences before giving me what I want. Not particularly impressive at this stage because it's all in the same context window, but it is actually storing those memories, and we'll get into more how it stores them and why it stores them and how it categorizes them and then how it retrieves them, etc. But this is just a simple demo to begin with. Find me a hotel. Again, not particularly earth-shattering, not surprising that an LLM would be able to, in the context of one context, be able to respond properly there. But we'll see here that in the background, as those turns have been processed, obviously it's storing the messages that were sent by me, but then we can see some other categories for memory: episodic, preference, and so on. So let's get into this taxonomy of agentic memory. And this isn't just plucked out of thin air. It's actually based on research, cognitive neuroscience research based on how the brain works. So this has been the inspiration going all the way back to the 60s with Atkinson and Schifrin and their paper on how the human brain is divided into 3 kinds of memory: sensory memory that's only lasting milliseconds but very broad in scope, literally everything that passes through your senses. Short-term memory lasts for seconds to minutes, a much smaller subset, and then long-term memory is what we remember for our lifetime. And these have these are analogous to how we're now starting to think about agentic systems. And what this leads to, or what this led to, is papers by Endel and Tulvig and Cohen and Squire. Endel, Tulvig, just one person, and Cohen and Squire, who between them defined different taxonomy of the different kinds of memory that would pass through those states. Okay, so episodic memory would be personal experiences. I went to Paris last summer. Semantic facts and knowledge would be things that don't change. Paris is the capital of France, and so on. And procedural would be learned workflows of how to do things, how to ride a bicycle. And you can see the analogs there for our mapping in this travel experience. And this is just so to give this a more crystal clear understanding. What this has led to is defining 3 types of memory that you would typically store in an agentic system to make it efficient and able to recall memory at the right granularity and at the right frequency, extract memory at the right frequency. So declarative memory, again, semantic facts; procedural memory, behavioral patterns; and episodic memory would be events or episodes. In this case would be trip specific to a travel advisor. And you can see the examples there. Declarative: user is a vegetarian, needs wheelchair access. Procedural: prefers boutique hotels, budget, moderate tier, and so on. You can see there are different confidence levels assigned to those different types. So for declarative, much higher confidence, different TTL levels, so time to live, when that data will expire. If it's a declarative, if it's a semantic fact, we'll never expire it. Of course, it might be superseded, but we'll come on to that. Critical for filtering. For procedural, this confidence in that kind of memory grows over time, and that wouldn't necessarily last as long because behavioral patterns do change, and then episodic would be specific to the given event, and typically you would be compressing episodic memory into procedural memories as well. So this will be repeated a few times. If this is new and unusual, then don't worry. Storing memory as documents, nothing earth-shattering here. JSON document is very good for storing in general. Conversation history and complex multi-layered memory types as well. Some of the code here, again, recommend that you go and try the sample out if this is in any way new to you, but we'd be storing, of course, user ID, tenant ID if it's a multi-tenant application. Typically these things are, you have many users, the memory type, which is those taxonomies that I just showed, the text, the user, the extracted text from the many different interactions and turns, facets, things to filter on, salience, which I'll come on to, justification, why that memory is stored, and then the embedding, the vectorized version of the text, the memory being stored so that it can be retrieved using a semantic search or vector search later on. Okay, so on to salience scoring. So really the formula that you see here, salience equals importance times confidence times recency decay, is more conceptual. The way it's implemented, at least in this application and many others that we've seen, is more in sort of three phases. So the initial phase would be the LLM will assign an initial salience score during the extraction process. So it will be based on the strength of the user's sentiment. Okay. And then the next phase would be something like reinforcement boosting is often how it's phrased as. So if a preference is confirmed a repeated number of times in subsequent conversations, then you'd increase the salience by a certain amount. The default in this is 0.05 as a value, but these are arbitrary. The point is you would be reinforcing that, boosting off the salience value. And then the final phase would be a retrieval ranking. So that literally just means it has a salience value. It also has a date when it was stored, and the most recent memory with that salience score would also be taken into account in the ranking. So if it's, this is what we mean by recency decay, and that's what I mean by the fact that this is conceptual. It's being implemented in a roundabout way. It's not directly implemented from the formula, is what I'm trying to say. And by the way, this is explained in much more detail in the sample and particularly in the workshops if you wanted to go through that and learn as you're doing. So in terms of the memory life cycle, of course, you're writing memories. Those are being extracted from the conversation, extracted as facts and stored with embedding. You would be retrieving those memories when the user is asking something that requires, let's say, a tool call, and that tool could be better served by extracting the memory rather than having to ask 20 questions in order to get that. Again, this is all about making your agentic apps more efficient instead of having to make multiple calls to an LLM to ask a question, and literally it's often the same thing that it's always asking. If you're storing the memory and retrieving it in an efficient way, then obviously that is going to save cost. Summarizing those memories I mentioned earlier on, episodic memories would be compressed after n number of terms, and this is a background process that's going on continuously. Some memories would be superseded if user says, I'm not a vegetarian anymore, or something else, then the memory would be flagged as superseded, not necessarily deleted, but every memory, apart from declarative memories, would have a time to live, and so you'd have an expiry time pretty much for every type of memory other than declarative, as I said. So a little bit more practical slide here. So how the retrieval process would work, just repeating what I've been saying really, but it's recall memories function, passing user ID, tenant ID, the query, so the question being asked, or the thing that's being said in the context of the conversation, the minimum salience amount that we're willing to tolerate. So there'd be a structured pre-filter, filtering on user ID, and the salience value that's been comprised in that manner that I described before. and has not been superseded. So that's our initial filter. And then we're doing a semantic search for everything that passes that filter that is semantically similar to the text that's being passed in. And then the final thing being that recency sort of cut off everything that's most recent k equals 5 or most recent. So to some extent these are arbitrary. The principles of doing it in this way has been well proven. You may tweak or change certain aspects of the different stages, but these seem to be pretty well tested by this point. So session level versus per turn persistence. Here I'm just saying that in the context of the sample, if you go and look at it, that's being handled by, the session level stuff is being handled by the check pointer capability in the LangGraph LangChain package. But the memory toolkit is doing the per turn memory extraction stuff. So the long-term memory aspects, extracting facts and so on. So little demo here. Of recall. So I had showed the memories earlier in the app, but let's just look at them in the database. So you can see there's a turn, there's an episodic memory, and there is a fact, declarative, or in this case, so this is a declarative fact. You can see the embedding and so on. And so I think what I do here, again, that's the problem with recorded demos. You have to remember what you actually did. So I think what I'm going to do here is I'm going to go in and ask similar question to what I asked before, but this is a new session, so it should be remembering or retrieving using that process that you saw before. The memories before doing a tool call and responding. And so it said, I found some great restaurant options for dinner tonight in Tokyo, keeping in mind that you're a vegetarian. And then I think all I was just showing here was the fact that every tool call that requires or can be enhanced by memory is preceded by the memory recall. That's all I'm showing here in the logs. Where is it? There we go. Hotel agent completed, and you can see, you can see recall memories there, and then the discover places tool. So that's that. So just again, a bit of a recap, or just talking about how the multi-agent stuff is set up in this travel app. It's very similar to the other app that I showed 12 months ago. Coordinator agents for specialized agents that it will devolve responsibility to. I already showed how the code looks. Graphs, not chains. So I don't know if you realize, most of you maybe will have, multi-agent systems are not linear pipelines, right? So you're always going to be having different agents that are going to be communicating with each other and routing to each other with branching logic, and they're also going to be having to have repeated loops of each of their processes and maintaining state of the whole system. As soon as you start doing that, what you're really talking about is a graph, right? Whatever the framework is that you're using to orchestrate this thing, whether it calls itself a graph or not, and it's going to end up being a graph. So I kind of like the fact that LangGraph calls itself a graph. That's nice. Very cognizant of what actually is going on. Yeah, tools versus MCP in this particular sample. Don't care whether you use MCP or local tool calling. Of course, there's an advantage of exposing MCP tools because then any agent from any framework can consume them rather than it being a stovepipe system. So again, just not really repeating, but just from a different angle, you saw what the memory recall process was and the retrieval process was. So this is it in context when user is asking something, find me a hotel in Tokyo. Agent responds with, agent then does memory recall, and the query is going to be this. That's a mistake, actually. The query would be what is in the user there. So I don't know why I've put that there. And then memory returns with prefers boutique and budget, moderate, quiet area, and so on. And those are the things that are then fed into the tool call, right? So you can imagine if you weren't doing this and weren't doing an enhanced and sophisticated memory extraction, the LLM would have to be asking questions repeatedly every time it talks to somebody in order to get the information it needs to do each tool call, right? And this can get very complicated. This is a contrived example, obviously, but when you're dealing with complex tool calling and complex systems that need to gather lots of information, quickly ramps up what information needs to be retrieved, really helps to be able to record memory and personalized aspects of what people are wanting so that it only has to retrieve from memory and the LLM is not too taxed and therefore not too expensive. Cross-agent memory sharing. All this means is that what one agent learns all benefit from. I have to be honest, I kind of dislike when I don't see it often to be fair, but when I see agentic systems showing the different agent, multi-agent systems showing the different agent that the person is talking to. So the user kind of gets the impression that they're talking to all these multiple different agents. I don't really get why that's required, really. The only reason why we do multi-agent apps is statistical, right? You're much more likely to get a better result if you are circumscribing tasks to one specialized agent and having it hand off to other agents. That's more likely to get you a better response, a more accurate and more appropriate response than having a single agent with tons of tools that it can call and exploding its decision space. So that's why we do it. So there's no need to surface to the user that there are multiple agents in the background. It's just one agent as far as they're concerned. So this is really an implementation detail from my point of view. All the different agents are able to share the same memory. If one agent learns something, that memory is stored and every agent can access it. So, yeah, just some syntax of how tools are set up. This is more in a multi-agent setup space. So you can see there the tools have been extracted from an MCP server, and then you're passing in an array of tools that the agent can call, along with the model and the system prompt for that agent, create React agent in LangGraph. So a little demo then of multi-agent coordination and memory sharing. And I'm showing the command line and the API in the background just so you can see the agent handoffs, because we're obviously not presenting this to the user. So user starts by asking, I'm planning a trip to Barcelona, find me some great restaurants. And so it's going to route that more than likely to the dining agent. There you go. So you can see it's been routed to the dining agent. And then it's going to do memory recall somewhere, and a background process is kicking off independently, asynchronously trying to process memory. I can see that you're a vegetarian. Let me share some great restaurant options. And so what do I say next? I could do with memory enhancement myself. I love the tapas places, but I also want somewhere with a C view. So again, still with the same agent, orchestrator is routing, and then again, background processes are running. And I think I now ask a question, now find me a hotel. So of course this is going to, and it learned, the dining agent learned some new information there, and that was processed. Now it's routing to the hotel, but the hotel agent is going to invoke the exact same memory recall, and it's going to have the same memory exposed to it. So that's all this is showing here. Just a little sort of side tip, not sure whether you'll need this or not, now that it comes to my mind. It's quite a topical debate at the moment within our team, with other teams that I know that are building agent systems, is exactly how much to allow the LLM to handle control flow. Sometimes this is not necessarily straightforward, but what I've come to the conclusion of, you can take it or leave it, is let the agent do things that are genuinely, where there is genuinely not one outcome that's supposed to happen. So let me give you an example. The coordinator agent, right? If you want, you can configure the coordinator agent to use an LLM to determine which agent to route to every time the request comes in. It's perfectly capable of doing that. But every time the request comes in and the user has already been talking to another agent, there's only one place it should go to. It's that other agent, right? So there's no reason for that to be well, I don't want to say non-determinate, probabilistic, right? LLMs are not non-deterministic. There's no reason to rely on an LLM for that. It's going to be slower and it's going to be less reliable. That should be deterministic. So what we've done in this particular app sample, we've taken an opinionated approach. We store the last active agent, and when the request comes in, the coordinator uses that deterministic piece of control flow to direct to the last agent it was talking to. No LLM involved. Okay, you don't have to do this. Lots of people have different opinions about this, but the more that you edge towards using the LLM for everything in terms of control flow, the very much slower it will get, and it will eventually crawl like a dog. So I'm just putting that out there. I say that because I know very good engineers who do this anyway, despite the fact that it really doesn't make the apps work very well. So making memory intelligent. I feel like I'm running out of time. How much time have I got? 15 minutes, great. Okay, so simple memory. We've kind of already covered this, but just to make it explicit, obviously if you're just storing manual storage, I don't eat meat, that's just, and relying on an LLM to process that without any explicit controls or anything guiding it, then it's not going to just capture a command. It may interpret it in the right way, and it may not. It's very, very much hit and miss. If you're not having conflict detection, then you could be storing user is a vegan and loves steak. Where's the process of deciding that that's a conflict and being able to resolve that? Context blind recall. So this is why we have different memory types. Episodic memory versus declarative memory. Episodic memory means we can say, okay, that's one episode. Doesn't necessarily mean it applies to this. It doesn't. We don't want those preferences to spill over into this other event, which is separate. And passive behavior, user forgets they have an allergy, LLM doesn't guide them in the right direction, then user drops dead because they ate some nuts or whatever. Obviously, these things are important. So this is why we do things like, well, everything that we've been talking about, automatic preference extraction. Ultimately, what this should lead to is, again, input, I don't eat meat and my partner has a nut allergy. LLM extraction happens, and we determine that there are some declarative facts that need to be used for the future. It's not, there's no explicit remember this needed, it's just the facts are there and they're going to be used in the memory recall process. Conflict detection and resolution. So again, this needs to happen. Semantic similarity and contradiction check. User is a vegan versus ordered steak. You need, in this particular app, and this is a best practice that we've seen, we're classifying severity. So this is ultimately implemented as a prompt. Obviously, there's a rubric of how you classify different severities. If it's critical, dietary safety, then we're going to ask the user to really, are you sure about this? If it's moderate, style change, then we might supersede it with a note, but then it will fall down the hierarchy in terms of recency if it's not reinforced, right? If it's not continually expressed. And then if it's context dependent, then we might store both with tags. And again, that will also fall down the pecking order in terms of recency if it's not reinforced. And then eventually the LLM will resolve it at some point. Given memory X and observation Y, determine whether we supersede it, coexist, or ask the user. And so then there should be an explicit function for that. And then auto-summarization, again, I've already alluded to it, but if you have 50 episodic memories, eventually we want to compress that into a procedural memory if there are common patterns, and this is happening all the time in the background in this particular implementation and others like it. The auto-flush pipeline, again, it's just describing what I've just mentioned. Facts are being extracted from the turns, but also summarization of episodic memory into procedural memory, detecting conflicts, and then updating the profile for that user, memory that relates to that user in a multi-tenant, multi-agent system, which many of these things are. Observability, I don't have much to say about this, but I really recommend taking a look at Langsmith if you're using LangGraph. And really, any multi-agent system, you need some way of seeing the lineage of what agents are being called, how they're being routed, and what tools are being called. Because this is a black box in terms of the control flow of code that you'll be using, whether you're using a coding agent to do the code or not. It's not going to be exposed very well unless you have tracing and observability that's built into the models and the tools themselves and can introspect them. All right, so intelligent memory extraction and conflict resolution. So I think I just had one little example of this happening here, or a couple of little examples. So, yeah, actually I've started eating fish and chicken now. I'm no longer strictly vegetarian. How's it going to respond to this? I mean, it's pretty, it decides, the strength of the statement. I've updated your dietary profile. It's come from the user. It's not a critical thing, so it's going to supersede in this case. So it stored that semantic fact, and it's removed the fact that I'm a vegetarian because I've told it that I'm not. Okay, and then I think the next one would be in the critical category. So my partner wants to go somewhere where we can eat nuts. I've already told it earlier on that my partner is allergic to nuts, and so it's just not having any of that, obviously. Should have asked me really, but it's asking me, it's confirming with me, because obviously that's been categorized as critical in this case. Right, so I've got 10 minutes to talk about what I really wanted to talk about, conversation as code. I probably haven't got time to go through all the slides, but I will flash up this slide. Can we agree that there is a big paradigm shift at least, right? I know that there's lots of discussions, lots of debate around whether we really can say natural language is the new programming language, or comparing it to LLMs to compilers, and all of the debates around that. We can agree it's a massive shift, right? I think it's the biggest shift personally since mnemonics and assembly moved into high-level languages and compilers. I mean, I actually think it's the biggest technology shift certainly in my lifetime, probably ever. I would say most people would agree it's the biggest shift since the internet. So, yeah, something has to be said about this. I'm not going to go through all of the slides because I think I just talk through the demo. But how we're actually working, and there's a few of you, I think less than half of you, maybe a third of you are using these things all the time. Just to show of hands, how many of you are using coding agents to at least do a bit of code? All of you, right? So this is totalizing, a totalizing shift. And obviously you'll all be working in different ways. But my sort of comment here is the same memory problem, just a new domain. How you exist when you're coding with agents. The point I really want to get across, if you remember nothing else, is when you're writing code yourself, you build up muscle memory of the decisions behind why you wrote that code. Right, that lives with you, and it's very easy to recall them when you're looking at it and even when you're talking about it and so on. But when you're vibe coding, I hate that term, but it's the popular one, or using agentic coding tools, that doesn't live in your brain, that lives in the conversation, right? So to me, the conversation is the code. That's the asset that you need to preserve somehow if you're going to have continuity for future projects. Okay, has anybody had the anxiety of thinking, I've lost the conversation with my agent? Where is it? Where's it gone? I need to, that's where because you're kind of existing symbiotically with the agent, right? It's most of the muscle memory is in that conversation. The agent has produced it and you've produced it together. So that's the thing I'm trying to get across here. Anyway, motoring through. Coding agent memory toolkit. This isn't public yet. The agent tools out there, Claude and Copilot, obviously, as a Microsoft thing, Cursor and others are doing a variation of this. Of course, I'm going to say that we're doing it more completely, but it is an open source tool, so it's going to be a little bit gnarly to begin with. The whole goal behind it is, again, different domain, same problem. You need to persist memory somewhere. Memory is a really big problem for coding agents right now. Let's just be honest about that. However you express it and however it is expressed or however it manifests. So anyway, you're asking the question, why was the code written this way, and so on. Again, the answer lives in the conversation. It doesn't really live in the commit message, because you can't link that commit message to anything that you can remember, right? It's much more easy for you to extract these things or persist these things in a systematic way, I would argue. So yeah, I'm going through these slides a bit too quickly here, but let's go through the demo. I won't go through the installation thing. Let's just see me doing a little bit of vibe coding here. So yeah, I'm starting off with build me a to-do API in Python with fast API. Keep it simple, just CRUD operations for to-dos with a title, description, due date, compilation status. It analyzes it. It does things, and very quickly it produces something. And I go, okay, great, but I want to sort of go in a slightly different direction. I don't want to raise HTTP exceptions directly in the service layer. What's a cleaner pattern for handling things like to-do not found and invalid output and so on? I guess what I'm showing here is, and you may work with coding agents differently. You may have more information in your head. You may give more directed instructions. You may give less directed instructions. It may be exploratory. I guess I'm trying to say people work in such different ways with these tools. But what's common to all of them is you're pushing the boat out. You're doing frontier work because obviously you're pushing these agents beyond what you yourself can do, at least in terms of productivity. That's most people's goal, is I want to get more productivity out of this. I want it to do stuff that I can do faster than I can do it. But lots of engineers I know are getting these agents to do things that they can't do or that they don't know how to do. They, in a programming language they've never touched. Or maybe things beyond their capacity, just stretching it as far as they can go, using what systems knowledge they have to guide it in the right direction. When that happens, then you have lost contact with the muscle memory that you would be gaining if you were doing it yourself, is all I'm saying. Where do you maintain it? Where do you persist it? Is the big question. I think this should be, conversations should be artifacts that live with the project and should follow you around. And I should be able to always anchor myself to them. Anyway, this is going on for too long and I've got 3 minutes left. I don't want you to deprive you of your dinner, so I'm going to go straight to the killer punch, hopefully, or not a killer punch, but just a nice thing. Imagine that it's done exactly the same thing that you saw before. It's been extracting facts and decisions and important things that I want to know about the code that's been written that I just won't acquire myself because I'm not writing the code myself. Wouldn't it be nice if I'd done tons of projects and I think, well, how did it do this thing? Instead of just getting the LLM to just trawl a load of code repositories again and blow a load of context or whatever, if I had maybe a nice slash command like memory that I could just put in and then ask a question. What's my preferred approach to input validation in Python APIs? And then just went to get my well-sourced and well-extracted compressed memory from Cosmos DB or whatever. I mean, this particular tool will only work with Cosmos DB. There'll be others out there, I'm sure. And then, based on your persistent memory, your preferred approach is to do this, and it's all nice and seamless, and I don't have to, And anybody think that's useful? Anybody? Yeah. Personally, this isn't actually why I did it, but I had to integrate with the memory toolkit, which provides that capability. Personally, the reason I did it was this, right? Oh no, where's my session gone? It's gone. I've changed the repo name, or I've moved on to a different machine. How do I carry on? Where is it? Right, and so I added this import thing. It's continually exporting the local chat session data into Cosmos DB, and then it can re-import it into your same chat tool or any other chat tool, Claude, Cursor, whatever. To me, that's sort of a comfort blanket thing. Obviously, I'm not going to be using the conversation memory in Cosmos DB all the time, but if I do lose it locally, because it's very ephemeral, isn't it? Right? There's nobody kept awake by this, that they're long conversations that they had building something very complicated. All the memory is just in your machine or whatever. Yeah. Cursor has that built in, you're right, but it doesn't have semantic extraction. Only Copilot does that. And Cursor will, actually no, it will export and import into local. VS Code doesn't. Copilot doesn't, sorry. So these different things, they're all doing variations of it. I would say, whether you use this tool or whether you use one of the others, just do it, right? Because one day you're going to lose your memory and you're going to think, oh yeah, that's where my memory was living because I exist symbiotically with agents, is all I'm saying. Yeah, just a demo of importing something that was done in VS Code into the Claude Code extension, which works the same as Claude Code. So, last slide. Right, in summary, memory is a data engineering problem, not a prompt trick. You need to have a real database, you need to be partitioning by user, TTL everything, have an extraction process that categorizes memory properly and compresses it properly and does all of those things that I talked about. 3 types, declarative, procedural, episodic. This is based on cognitive neuroscience research, not just plucked out of thin air. It works at scale. Hybrid retrieval beats pure vector search. Again, hybrid is an overloaded term already. In this case, it doesn't just mean vector search plus hybrid plus text search. In this case, it means salience pre-filter plus vector search and a recency sort in order to complete that formula for salience that I showed before. Intelligent lifecycle is non-negotiable. You really need to, just as having the right costs for different building materials, if you're building a bridge, is not negotiable. If you're going to do this properly, then all of these techniques need to be incorporated so that they actually implement everything else that you've designed. And I think the pattern is domain agnostic. I think it works also, it applies to coding agents as well. And that's it, bang on time, just about 1 minute.
Okay, thank you. Yeah.